Okay, welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to be looking at a final review of gas laws. I'm just going to do 4 of them here, so that way we can run through those and we'll get started on the next concept. We're looking at advanced gas law problems. So we'll start here by doing 2 gas law problems, one each way, and then 2 limiting reactants. The first one is a standard, just masses. Second one, I decided to get a little more intricate with you. We're going to throw a gas law in with a limiting reactant just to make sure we're good to go. All right, so let's do the first one. Find the mass of lead 3 oxide formed when 978.250 milliliters of oxygen react with excess lead at 78.255 degrees Celsius and 771.35 torr. Now remember, start with volume. We do gas laws first. We do stoichiometry first. Remember, when do we use 22.4? And it's a simple synthesis reaction right there. Number 2, determine the volume of carbon dioxide generated when 97.250 grams of zinc carbonate reacts with excess hydrochloric acid to an acid-base reaction, or otherwise a double replacement, at 24.5 degrees Celsius and 0.9895 atmospheres. I'm giving you mass, so remember which one you do first. And number 3, remember these are both mass of limiting reactant. Calculate the mass of silver sulfate formed in the limiting reactant and the amount of excess reactant that remains when 17.55 grams of silver phosphite reacts with 21.33 grams of lead 3 sulfate. So we're going to do both reactions, whichever is smaller, then take that limiting reactant, that's a limiting reactant, the one that gives you that number. Take that limiting reactant to the other reactant to find out how much was used, subtract it to find the amount of excess, and then finally the one that puts it all together, determine the mass of calcium oxide formed, the limiting reactant, and the amount of excess reactant that remains when 13.55 grams of calcium reacts with 15.11 liters of oxygen at 100.9 kilopascals and 71.55 degrees Celsius. Alrighty. So pause the video, screenshot, download, write it down, however you need to do this. Remember, if you have any questions, ltswpd@gmail.com. And remember to like, subscribe, share, so we can help others get this information out. All right, awesome. Now let's pause it, do your best. Ready? Okay, here are the answers. Number 1. Answer is 10.610 grams of lead 3 oxide. Number 2, answer is 19.19 liters of carbon dioxide. Number 3, we generate 20.38 grams of silver sulfate. The 28.44 grams of silver sulfate is too much. So silver phosphite is my reactant. We take the silver phosphite to the lead 3 sulfate, and we get 15.29 grams of lead 3 sulfate. We then subtract that, so we end up with 6.04 grams of lead 3 sulfate excess. And then for the last one, for number 5, we end up with 37.9. Well, first we do the combined gas law. When we do the combined gas law, we're going to generate 11.92 liters of oxygen. We're going to work it through. The calcium gives us 37.94 grams of calcium oxide. The other one gives us 59. That's too much. We then run the problem through, and we end up with an answer of 10.30 liters of oxygen excess. All righty. Hopefully not too bad. Take care. God bless. Bye. Give me a chance to see all the answers here. All right.